it's time to record.
So where did you get the number 3 from?
Well, and I just looked at it. I just examined it. Now we're going to use the formula, which is a much better way of figuring this out. So since 11 is 6 units above 5, or 6 units to the right of 5, and each standard deviation is 2 units, if I take 6 and I divide it by 2, I get 3. So 11 is 3 standard deviations to the right of the mean. So again, so if I take 11 and it's 6 units to the right of 5, and each standard deviation is 2 units, if I take the 6 and I divide it by 2, I get 3. So 11 is 3 standard deviations to the right of the mean for this normal distribution. Now there is a formula for this, and it's right here.
So it just basically reduces the number of 6 to 3.
Right. What it tells you is, let's review. So I have a normal distribution whose mean is 5 and whose standard deviation is 2. So I don't know what this distribution represents, and at this point I don't really care. But I know that maybe this is, I don't know, the number of shoes you have in your closet. I don't know. So on average, you have 5 pairs of shoes with a standard deviation of 2. Now, is that normally distributed? Yeah, probably. So maybe this is the number of pairs of shoes in the closet. So you have somebody who has 11 pairs of shoes. So what does that mean as far as how far they are from the mean standard deviation wise? And there is a point to this because we're going to talk about the empirical rule here in a minute. So what you do is you say, okay, they got 11 pairs of shoes. Well, that's 6 more pairs of shoes than the average. Okay, well, how many standard deviations is that from the average? Well, if each standard deviation is 2 units, then that's 3 standard deviations. 6 would be 2 times 3. Now, the easier way to calculate this is to use the formula. So if I have a normal distribution whose mean is 5 and whose standard deviation is 2, then the z-score for a data value of 11, and I'm just going to use a subscript of 11 to represent that, we take that data value, which is 11, I subtract the mean, which is 5, and I divide by this number of standard deviations. So to find the z-score for a particular z-score for a particular data value, you take that data value, you subtract the mean of your normal distribution, and you divide it by the standard deviation, and you get 3. So 11, the data value 11 is 3 standard deviations above the mean. And that's actually pretty significant that it's 3 standard deviations from the mean. So someone who has 11 pairs in their pairs of shoes in their closet, that's pretty high up there, 3 standard deviations. Most people, if the mean is 5 and the standard deviation is 2, someone having 11 pairs of shoes is kind of out there. I can talk about that some more here in a minute. So to find the standardized score for any particular data value, you take that data value, you subtract the mean of your distribution, and you divide that by the standard deviation. And that tells you how many standard deviations away from the mean that particular data value is. And we're going to look at the normal distribution here in a second. We're going to look at how many data values are plus or minus 1 standard deviation, plus or minus 2 standard deviations, plus or minus 3 standard deviations. If you're 3 standard deviations above the mean, that's pretty significantly above the mean. Okay? All right. So if you take a normal distribution and you standardize it, And you can standardize any normal distribution. Every normal distribution can be standardized. So if you standardize it, what happens is you force the mean to be 0 and you force the standard deviation to be 1. So the standard normal distribution is a normal distribution whose mean is 0 and whose standard deviation is 1. And the way we represent that is we use a capital Z for our random variable. Z represents that this is the standard normal distribution. The Z value is described by a normal distribution. So the standard normal distribution is described by a normal distribution whose mean is 0 and whose standard deviation is 1. So when you standardize a normal distribution, you force the mean to be 0 and you force the standard deviation to be 1. Okay? So what's the Z-score then of X when X is 1 and you have X being described by a normal distribution whose mean is 12 and whose standard deviation is 3? So when you see this notation, that means this is the continuous probability distribution. It's normal. Capital N means it's normal. The first number in the parentheses is the mean of this distribution. And the second number is the standard deviation. So if I want to find the Z-score for a normal distribution whose mean is 12 and whose standard deviation is 3, I can use the formula. So again, normal distribution, mean is 12, standard deviation is 3. Where is 1? Well, 1 is over here to the left of 12. So what is the Z-score for a data value of 1? So what we do, Z can be found by taking X minus mu and dividing it by sigma. So to find the Z-score for 1, we take 1 minus 12 and we divide that by sigma. So what this tells you is that a data value of 1 is 3 2/3 standard deviations below the mean, or to the left of the mean. So that data value is significantly below the mean. And again, I don't know what this normal distribution represents, but if you get a data value of 1, that's way to the left of the mean of your distribution. Okay, as a matter of fact, it's 3 2/3 standard deviations to the left of the mean. And you'll notice that when we calculated the Z-score for 1, we got a negative number. So X equals 1 corresponds to Z equals negative 11/3. So what that means is, if we standardize the normal distribution, then the mean is going to be at 0 when we standardize it. And that means that that value, X equals 1, is to the left of the mean. So when you get a Z-score that's negative, that means your data value is to the left of your mean. Okay, so what's the Z-score of a data value X when X is 14 and we have a normal distribution whose mean is 12 and whose standard deviation is 3? So again, that X squiggly line, capital N 12, 3 means that this distribution is normal. It's a normal distribution. The first number is the mean and the second number is the standard deviation. So again, if I draw a picture of it, the mean is 12 and the standard deviation is 3. So if I have a data value X equals 14, that is going to be to the right of the mean. So that's some data value to the right of the mean. So how do I find the Z-score of that. To find the z-score of an x value of 14, again, I take the data value, I subtract the mean, and I divide it by standard deviation. So the number 14 is 2/3 of a standard deviation above the mean of this distribution, whatever this distribution represents. And again, I'm kind of being, wishy-washy about what the distribution represents, because I don't know. I have no idea what this represents. Something that's normally distributed with a mean of 12 and a standard deviation of 3. But a number that's the number 14 is to the right of the mean. And as a matter of fact, it's to the right of the mean by 2/3 of a standard deviation. It's 2/3 of a standard deviation above the mean. So to find the z-score, we take the value of the data value, we subtract whatever the mean of our distribution is, and we divide it by our standard deviation. If the data value is to the left of our mean, we're going to get a negative z-value. If the data value is to the right of our mean, we're going to get a positive z-value. So we get a negative z-score. If our data value is to the left of the mean, we get a positive z-score if our data value is to the right of the mean. Okay. Some doctors believe that a person can lose 5 pounds on average in a month by reducing his or her fat intake and by exercising consistently. Suppose weight loss has a normal distribution. So they're telling you that this is a normal distribution. Let X, our random variable, be the amount of weight lost in pounds by a person in a month. So our normal distribution is going to describe, all these values are going to describe how much weight someone loses in 1 month. So they tell us on average, if you follow this plan, you can lose 5 pounds. So the mean of this normal distribution is 5. And they tell you that the standard deviation is 2 pounds. So this is a normal distribution. The random variable, the amount of weight you lose in a month, is normally distributed with a mean of 5 and a standard deviation of 2. And that's what this is describing right there. So the weight that a person loses in a month is normally distributed. Well, I should say the weight a person loses in a month, if they follow this plan, is normally distributed with an average of 5 and a standard deviation of 2. So let's see if we can't fill in the blanks. Suppose a person lost 10 pounds in a month. Well, that's above the mean, right? The mean is 5. What if they lose 10? What's the z-score when you lose 10 pounds? How far above, how many standard deviations above the mean is 10 pounds? And it tells me that it's 2.5. Let's verify that. So I'm going to draw myself a picture because I am nothing without a picture. So it's a normal distribution whose mean is 5 and whose standard deviation is 2. So 10 is over here. So 10 is to the right of the mean. So how do we find the z-score? We take the data value, which is 10, we subtract the mean, and we divide by the standard deviation. And that's 5 over 2, which is 2.5. So 10 pounds is 2.5 standard deviations above the mean. So you're losing 2.5 times more than the standard deviation. Okay. So the z-score tells you that when X is 10, that's 2.5 standard deviations to the right of the mean, 5. So 10 pounds is 2.5 standard deviations to the right of the mean of this distribution, which is 5. All right, same distribution. So this is a weight loss program with a mean of 5 and a standard deviation of 2. So suppose somebody gained 5 pounds. That would be me. So suppose someone gained 5 pounds. So what this means is your weight loss is negative. Would that be correct? So if we look at loss, weight loss, as a positive quantity, so if I lose 5 pounds, that's to the right of the mean. If I gain 3 pounds, then that is a negative weight loss. So what's the z-score? So our x would be -3. So I'm getting some significant lag here. All right, so if x is -3, how do you figure out the z-score? Well, the z-score for -3 would be, well, my data value is -3 minus the mean, which is 5, over the standard deviation, which is 2. So the z-score for a weight gain of 3 pounds is -4. So what this means is that you're 4 standard deviations to the left of the mean if you gain weight. If you gain 3 pounds, you are to the left of the mean. And if you gain 3 pounds, you're 4 standard deviations to the left of the mean. You are not following the plan if you gain 3 pounds. So z is -4. The z-score tells you that x equals -3 is 4 standard deviations to the left of the mean. So if your z-score is negative, that means you're to the left of the mean. If your z-score is positive, you're to the right of the mean. If your z-score is negative, you're that many standard deviations below the mean, to the left. If your z-score is positive, you're that many standard deviations above or to the right of the mean. Okay, so let's see if we can do this example. Suppose the random variables x and y have the following normal distributions. So the random variable x is defined using the normal distribution with a mean of 5 and a standard deviation of 6. Remember, when you look at this, the capital N tells you that it's a normal distribution. The first number inside the parentheses is the mean, and the second number is the standard deviation. So the random variable x, whatever that represents, is described by a normal distribution whose mean is 5 and whose standard deviation is 6. The random variable y, whatever that represents, has a normal distribution with a mean of 2 and a standard deviation of 1. So the means are different and the standard deviations are different. So what if x is 17? What's the z-score for a data value of 17? Now 17 is going to be to the right of the mean, correct? 17 is bigger than 5. So z of 17 for the normal distribution with a random variable x would be 17 minus 5 divided by 6, which is 12 over 6, which is 2. So 17 is 2 standard deviations to the right of the mean. Okay, Now let's look at the second normal distribution, the random variable y. Let's find the z-score for y is 4. So this is x, this is y. Okay, oops, giving it away. So we're going to take the mean, which in this case, excuse me, we're going to take the data value, which is 4. We're going to subtract the mean, which is 2, and we're going to divide it by the standard deviation, which is 1. So it is 2. So what you can see here is that we get the same z-score with two completely different distributions, and that's okay, that's fine. Because what this tells you is that in the random normal distribution that describes the random variable x, that 17 is 2 standard deviations above the mean. The standard deviation for that particular distribution is pretty large. I mean, if the mean is 5 and the standard deviation is 6, that's a pretty good spread of data. The second distribution, the mean is 2, but the standard deviation is 1, so the standard deviation is pretty small. So a data value of 4 is 2 standard deviations above the mean because the standard deviation is a pretty small number. One's not a huge standard deviation. So you can see that you have 2 completely different normal distributions. The cat got in, by the way. He figured out how to open the door. You know, for such a, he's not real bright. As a segue, I hate that this is going to get recorded, but as a segue, this cat was rescued from a burning hotel. So there was an abandoned hotel that caught fire, and a mama cat and her kittens were living in this, they were feral, were living in this hotel, and he's the only one that survived. And he was resuscitated by the firefighters. They actually put oxygen on him and brought him back to life. So he's not all there. He's got brain damage, but I mean, he still figured out just now how to open the door, but he doesn't remember. He has really bad short-term memory. So he doesn't remember. So you feed him and he 5 minutes later doesn't remember he's been fed. So he's got short-term memory issues, but anyway. Okay, enough of that. Okay, so the empirical rule. If x is a random variable and has a normal distribution with mean mu and standard deviation sigma, then the empirical rule states the following. So if you have a normal distribution, mean mu, standard deviation sigma, about 68% of all the x values will lie between plus or minus 1 standard deviation from the mean. So if it's a normal distribution, if your data is normally distributed, you should see 68% of your data lying between plus or minus 1 standard deviation from the mean. You should see 95% of your data lying plus or minus 2 standard deviations from the mean. If it's normally distributed, approximately 95% of all the x values will be between -2 sigma and +2 sigma, or within 2 standard deviations of the mean. And 99.7% of your data should be within plus or minus 3 standard deviations from the mean. So when we got that standard deviation just a minute ago of -4, well, that's way out there. That's beyond plus or minus 3 standard deviations. It's beyond 99.7%. So that's somewhere in that 0.3%. That's not between plus or minus 3 standard deviations from the mean. So that's pretty significantly out there. So that's what the empirical rule says. So again, the z-scores for plus or minus 1 standard deviation from the mean are plus and -1. The z-scores for 2 standard deviations and -2 standard deviations from the mean are +2 and -2. And the z-scores for plus or minus 3 standard deviations would be 3 and -3. And the empirical rule is frequently called the 68, 95, 99.7 rule. So about 68% of your data will lie between plus or minus 1 standard deviation from the mean. Approximately 95% of your data will lie between plus or minus 2 standard deviations. I'm getting that internet connection unstable. About 95% of your data should lie between plus or minus 2 standard deviations from the mean. And about 99.7% of your data should lie between plus or minus 3 standard deviations from the mean. Okay. So suppose X has a normal distribution with a mean of 50 and a standard deviation of 6. About 68% of the X values lie within 1 standard deviation of the mean. So about 68% of your data values will lie between, okay, so my mean is 50 and my standard deviation is 6. So about 68% will lie between 50 minus 6 and 50 plus 6. So about 68% of my data values will be between 44 and 56. About 68% will be plus or minus 1 standard deviation from the mean. All right, if I have the same normal distribution, mean is 50, standard deviation is 6, then 95% of your data, your X values, will lie between plus or minus 2 standard deviations from the mean. So if I take the 50 and I subtract 2 standard deviations, and I take the 50 and I add 2 standard deviations, I get 38 and 62. So about 95% of my X values will be between 38 and 62. And then last but not least, plus or minus 3 standard deviations, same normal distribution with a mean of 50 and a standard deviation of 6. 99.7% of your X values will lie between plus or minus 3 standard deviations of the mean. So if I take 50 and I subtract 3 standard deviations, and I take 50 and I add 3 standard deviations, I get, what is that? 32 and 68. So approximately 99.7% of all the other cat just came in. One cat opens the door, the other cat comes in. She's liable to jump on the desk. 2 cats. Used to have 4. Now I just have 2. Used to have 4 cats and 2 dogs. We're down to 2 cats. Yeah, we were kind of crazy. Anyway, so 99.7% of our percent of our X values, our data values, should lie between 32 and 68. Okay, so we're going to break out that TI-84 calculator. And I'm going to show you how to find these probabilities using your calculator. Now, all of these are standard normal because you're looking for the probability of a z-score being less or greater than or between 2 values. So this is standard normal when you see the z. So a standard normal distribution has a mean of 0 and a standard deviation of 1. So if it's a standard normal distribution, mean is 0, standard deviation is 1, and we're going to figure out what's the probability of having a score, z-score, less than 2, or what's the probability that I'm going to be 2 standard deviations below the mean. So if I draw a picture of this, mean is 0, 2. What's the probability that I'm 2 standard deviations below the mean? Oh, that's not right. That's not right at all. I think 2 is to the right of 0. The cat's distracting me. So that's what we're looking for. And remember, the area underneath the curve represents the probability. So what I've shaded there, that area under the curve, is the probability that z is less than 2, or z is to the left of 2. And my calculator can calculate this for me. So let's open up our calculators, and then I'll show you the table. You'll appreciate your calculator. All right. So here's my calculator. So I'm going to use the normal distribution to find the area under the curve to the left of 2. So I'm going to go to my distribution menu. So I'm going to go second, variables, to my distribution menu. And we're not going to use number 1. Not going to use that at all. We're only going to use 2, which is the cumulative normal distribution. All right, so let's just click on that and see what it looks like. All right, so the normal distribution, you should have an upper and a lower limit. And then you should have a value for mu, the mean, and a value for sigma, the standard deviation. So the lower limit in this case, we're looking for the probability that z is to the left of 2 or less than 2. So the lower limit, let's go back to our picture. So if we look at our picture, which I'll come up here in a second, here it comes. If we look at the drawing that I did, the lower limit for the area under the curve is way over there to the left somewhere. As a matter of fact, it's to the left, infinitely to the left is where it's at. So the lower limit for this area that I've shaded is negative infinity. The upper limit of this area that I've shaded is 2. So again, I'm looking for the probability that z is less than 2 or to the left of 2, but I have to give my calculator a lower and an upper limit. So the lower limit is infinitely to the left, and the upper limit is 2. So what I tell my calculator is that the lower limit is some itty bitty teeny weeny tiny number. So what I use is negative 1 times 10 to the 99, which is a really teeny weeny itty bitty tiny number. Okay, so we're going to use a lower limit of a really small number. We're going to use negative 1 times 10 to the 99, which is a really, really, really far to the left. And that'll be good enough for our calculator to calculate. Okay, so negative, that's what that means when it comes up. That negative 1, E99, that's what that means. Negative 1 times 10 to the 99. This is scientific notation. When you see the E on your calculator, that means times 10 to the 99. So to get scientific notation, that is the EE above your comma. So if you want to write a number in scientific notation, like 2 times 10 to the 5th, you'd say 2 EE and then 5. So 2 times 10 to the 5th would be 2 EE 5. So we have negative 1 times 10 to the 99, a really, really small number. Our upper number, so we're going to hit enter, was 2. So we're finding the area underneath the curve from negative infinity to 2. So we're going to type in 2. And since this is a standard normal distribution, we're looking for z-scores. The standard normal distribution, the mean is 0 and the standard deviation is 1. So we're going to leave those, and then we're going to hit paste. So what we see back in our home screen is that we're going to do a normal cumulative probability distribution. The lower limit is -1 times 10 to the 99, comma, the upper limit. So the first number is the lower limit. The second number is the upper limit. So that tells your calculator what area under the curve I'm going to find. I'm going to find the area from negative infinity to 2 with a mean of 0 and a standard deviation of 1. So the first number is the left limit, the lower limit. The second number is the right limit, the upper limit. The third number is the mean of the distribution. And the fourth number is the standard deviation of the distribution. Since we're looking at a standard normal distribution with z-scores, we use 0 for the mean and 1 for the standard deviation. And we'll hit enter. And it's 97.7 or percent, 0.977. So the probability of me getting a value less than 2 is 0.9772. Oops,
Okay, so whenever I did it in my calculator, it didn't bring up the lower and upper.
It didn't? Okay,
No.
so you have a calculator then. You have a calculator that finds the area to the left. If your calculator does not show a lower limit, then what it's finding is everything to the left of your number. So if you type in just the 2 for the upper, you should get the same value. Now, where this is going to get tricky is the third one here. So we'll have to talk about that when we get to it. So trust me, we'll do it. So if your calculator doesn't have a lower limit, it's assuming the lower limit is negative infinity. Okay. And I don't know what.
So just put the -1 e not to the 99 and then comma 2.
No. Let me see if I can get. What calculator do you have, Aunt Leisha?
10i84 plus silver edition.
84 plus silver edition. Okay, see if we can get that skin on there. I think this is the same one. Okay, so let's do our distribution.
Okay.
And I'm sorry about it. It makes it so big. It's just the way the emulator works. So do you see this when you go to that distribution?
No, it doesn't even pop that up. I'll show you.
Can't see it, and Alicia, I can't see it.
I'm trying to turn the camera.
So it just has the normal CDF with parentheses.
Mm-hmm.
Yeah.
So
okay.
whenever
So
I do the
that's what you're
second,
going to do.
The bars,
so you're going to type.
Up.
Yeah, you're going to type in -1 EE99, comma 2, comma 0, comma 1. So let me go back and write that down.
Okay, I got it now.
So you would type in normal CDF, comma, parentheses, -1 E99, 2, comma 0, comma 1. So yeah, you have to type all that stuff in. Sorry about that.
It's fine. I got it now.
That's why every time I send you guys something, a PDF of instructions, I always write it out this way so that if your calculator doesn't give you that screen where you can just type stuff in, you're going to have to type it in using the commas. All right, so what about finding z is greater than 2? To find z is greater than 2, well, you can do it a couple of different ways. Now, you could say, okay, z greater than 2, let's shade that in a different color, if my calculator will let me, if my computer will let me. Greater than 2 would be this area that I just shaded in blue, correct? To the right of 2. So you could, since the area, total probability, the total area under any continuous probability distribution is 1, you could take that less than 2 and subtract it from 1. You could do that. And you could find the probability that z is greater than 2. Or using your calculator, you just change your lower and upper limit. Let me show you how to do that. Because what you're going to do, if you're interested in finding the probability, the area under the curve to the right of a number, then your upper limit, you're going to type in a really big number. Okay? Now again, since I'm going to change my skin back to something a little bit easier for us to see. Okay, so again, what we have here is the area under the curve to the left of 2. So if I want to find the area to the right, I can just subtract that number from 1. I could do that because the total area under any probability distribution, any continuous probability distribution, is 1. Okay, so I could do that. But I can also use my calculator. So I'm going to go back to my normal distribution. We're going to use number 2. Now, my lower number, my lower limit is 2. So I'm going to type in 2. In my upper limit, I need to type in a really big number because I'm wanting it to go to infinity to the right. So I'm going to type in 1 times 10 to the 99th, a really big number. So 1 EE, second, comma, EE, 99, which is a really big number. Okay? And then I'm going to leave my mu as 0, my sigma is 1, enter. So this is what you would type in if your calculator doesn't give you that screen where you can type in the lower and the upper. Your lower limit is the first number, 2. Your upper limit's the second number, a really big number, 1 times 10 to the 99. Your mean is 0, and your standard deviation is 1. 0.02275. And again, you should be able to see that if I take those two numbers on my TI screen, the 0.9772 and the 0.0228, and I added those together, I should get 1. So the area to the left of 2 plus the area to the right of 2 should equal 1 because the total area underneath the continuous probability distribution is the number 1. So we got 0.275. Okay, now how do I find the probability between two z values? So if I draw a picture of this, This is between -2 and +2. So I'm going to find this area here. Well, it's just a simple matter of telling your calculator the lower limit is 2 and the upper limit, the lower limit is -2 and the upper limit is +2. Now you should know what this is because the empirical rule says that 95% of your data values should be plus or minus 2 standard deviations from the mean. So what you should get when you do this is 0.95, 95%. Let's do it on our calculator and see if that's true. Because the empirical rule says that 95% of your X values, your data values, should be within plus or minus 2 standard deviations of the mean. Okay, so now all I'm going to change on my calculator is the upper limit for this and the lower limit. So I'm going to go back to my distribution. So now the lower limit is -2. The upper limit is +2. %, which is what we anticipated from the empirical rule. It should be 95%. 68% of all of our X values are plus or minus 1 standard deviation from the mean. 95% are plus or minus 2 standard deviations, and 99.7 are plus or minus 3 standard deviations. Okay, so just to make you feel good about your life and that you spent money on this thing or you rented it some way or another, you either somebody gave it to you or you spent money on this thing, this calculator here. To make you feel good about that, I'm going to show you what I had to do. And as a matter of fact, since I don't require the quantitative reasoning class to buy a graphing calculator, maybe I should, they have to use a table for this. It's called a standard normal table. So what somebody did is they did all these calculations for you and put it in the table. Aren't we glad that we have people that will do that for us? And it's right here. I have it in Excel. So this is when it comes up. Being very slow. This is the standard normal table. So you can calculate the areas to the left of a particular z-score. So we looked at what z is less than 2. So what you do is you go to this table and you find z is 2, which is right there. There's 2. So that is z is 2. And the number to the right of it is the area under the curve for a z-score of 2. So it's the area to the left of 2, the area under the curve, which is 0.9772. That's what we found on our calculator. Exactly the same thing. So again, what are the 2 advantages of getting old? Telling people how much you should appreciate that you live now and not then. And grandchildren. Those are the 2 perks of being old. So this is what we did not too many years ago before we had a really nice calculator, that to find the area under the curve to the left of a number, a z-score, we had to go to this table and use the table to find it. Aren't we lucky that we live in an age when we can spend, I know, a lot of money, I'm sorry, a lot of money on a calculator that will do this for us. Okay, let's go back to PowerPoint. Okay, now here's a different question. So what are they asking me here? What they're asking me is, what is C, or what's the data value if I'm looking for the probability of Z being less than this number C being 0.3? How confusing is this? So what they're giving you, do you see what they've given you? They're telling you that the probability is 0.3. Probability is 0.3. And probability is area under the curve. That's how you find the probability. So when we were just now in our calculator finding the probability that z is between -2 and 2, we found the area underneath that curve from -2 to +2. That's what we did. So now they're telling me the area under the curve is 0.3. What is the z-score? Standard normal distribution. And they're saying that the area, so we have some c here, some number, some x value. The probability that z is less than that number or to the left of that number is 0.3. So what they're giving me is the area under the curve. So when they give me a probability, it is the area under the curve. So how do I figure out what z-score applies to an area under the curve of 0.3? So now it's different than what I just did. Before, I had a z-score and I found the area. Now I have an area and it wants me to find a z-score. It wants me to find what value of z is the area to the left of it, 0.3. The area under the curve to the left of that value is 0.3. So what we're going to use is what's called the inverse normal distribution. It's on your calculator, and all you have to tell it is the area under the curve and your mean and standard deviation. So let's go back to our calculators. All right, and I'm going to go to my distributions again. And number 3, do you see number 3? That is the inverse normal. So if they give you a probability, so they give you the area under the curve, you're going to use the inverse normal to find the z-score or the x-score if it's just a normal distribution. We'll talk about that later. Well, in this case, we're going to find the z-score that corresponds to the area under the curve being 0.3. So we're going to use number 3. And you see that it asks me for the area. And in our case, it's 0.3. Now, not every calculator that we have in this classroom has the tail, the left, center, right. If you have an older calculator, it's not going to have the tails. What your calculator will find if it doesn't have the tails is the left. It defaults to left. And if your calculator doesn't have that, that's what it's going to find, is the area to the left of that value, which is what we're looking for anyway. So it's a standard normal distribution. So the mean is 0. The standard deviation is 1. And again, if your calculator doesn't have the tail there, that's okay, because it's finding the area to the left. So it's defaulting to left. So this is what it should look like. If you don't have the left or right, it should be 0.301. And if you have a newer calculator, it's finding the area to the left. If not, it's defaulting to finding the area to the left. So like a TI-83 will default to the left. That's the area that it's using. So that's -0.5244. So a z-score of -0.5244, the area to the left under the curve is 0.3. So this value of C, this number right here, is -0.52. .5244. And that is a good place to stop for today. 6.2, we're just going to use a normal distribution. We're no longer going to standardize it. So in section 6.1, we looked at the standard normal distribution. That's that distribution whose mean is 0 and whose standard deviation is 1. And we can find the z-scores by taking our data value, subtracting the mean, and dividing it by the standard deviation. And the z-score tells you how many standard deviations from the mean that data value is. You don't need to do that. Given a normal distribution, any normal distribution with any mean and any standard deviation, if you look at your calculator again real quick, and we look at the normal distribution, you can let the mean be anything. So your calculator can handle any normal distribution whose mean is mu and whose standard deviation is sigma. So it can find the area under the curve, the probability for any normal distribution. All you have to do to find the area under the curve is tell your calculator the lower limit, the upper limit, whatever your mean is, and what your standard deviation is. And your calculator can find the probability, which probability is equal to the area underneath that normal distribution curve. So whatever your curve is, it can find the area underneath it for you for any infinite number of normal distributions. And on Tuesday, we'll do a couple of examples of finding the area under the curve or the probability given a normal distribution. Are there any questions? Have you all typed your name into chat? If you have, then I'll let you go and we'll talk to you hopefully in class. Have your fingers crossed that the water issues are resolved. Talk to you on Tuesday.